Okay, so today's lesson is on multiplying and actually adding and subtracting fractions. Yesterday was multiply, divide. Today is add and subtract. And you see two guidelines to follow when you add or subtract fractions. When we circle addition and subtraction, that'll focus us in on the idea that our fractions, when we add or subtract them, have to have a lowest common denominator. We need an LCD. And our denominators can only be changed by multiplying the overall fraction by something equivalent to 1. So in exercise 1 it says combine each of the following fractions by first finding a common denominator. Express your answers in simplest form. So that means in the end, leave your fraction's denominator in factored form in case you can cancel some factor in the denominator with some factor in the numerator. Okay? Now, in letter A, it's addition. B and C are too. So we need an LCD. So on the side of our papers, when you need an LCD, I always want you to state what your lowest common denominator is. So when we look at the coefficients of the denominators, the 4 and the 6, we're looking for the least common multiple of 4 and 6. The lowest number they both will go into. It's like counting by 4s. 4, 8, 12, 16, etc. And 6, 12, 18. What's the lowest multiple they have in common? 12. Now you could use 24 for this, but it take longer and you make your numbers higher, and you most definitely would have to reduce in the end. So you really want to choose the least common multiple, which is a 12. Now, we're in luck. They both already have an x in common. So that's part of our LCD. They both already have it. So once you identify the LCD, then you make a big long fraction bar and really try to organize your work and not crunch it all together. And you bring the LCD down in your new denominator, and now watch my pen and my finger. Okay, watch, please. Now you have to compare what you have in the first denominator to what you need. You have a 4x, we need a 12x. What factor are we missing? A 3. So now we have to multiply the top and bottom of the first fraction by 3. Now, if we multiply the top of it by 3, the top is a binomial. We have to hug the binomial with parentheses, so we're going to front multiply it by 3. So put your dot in for times. We're going to multiply the top of that by 3 and the bottom of that by 3. Now notice what we get in the denominator now. 3 times 4x is 12x. And we distribute 3 inside the parentheses. We get 6x minus 15. Make sure you bring down your connector sign. It's add. Now, again, we compare what we have, and my pen is on that right now, 6x in the denominator, to what we need in a denominator. My finger's tapping on it. What are we missing a factor of? A 2. They already both have the x, so we're missing a factor of 2. So we're going to try to squeeze in the dot and the 2 and hug the top binomial with parentheses. We're going to multiply the top and bottom of it by 2. And that's going to give us 12x in our denominator, which we need. It's going to give us what we need in our denominator. So 2 times 4x is 8x plus 4. Now I don't want to use this space over here, which is supposed to be for B, for A. So I'm going to make an equal sign. I'm going to make a road map. Okay? Many of you are getting good at doing that now. That's good. That helps people follow your work. And combine like terms. Add the stuff in the top, or subtract it depending on the signs. A 6x and a positive 8x make a positive 14x. A negative 15 and a positive 4 make a negative 11. And that's all over 12. Now at this point, you know, you have to see, thank you, 12x. I did the same thing in Mod 1. Thanks for catching that again. Okay, I was about to say that you now have to think about simplifying it. And simplifying it means to see if you can factor either the top or the bottom. 14x minus 11 doesn't factor at all. It's not the difference of squares. And 14 and 11 are relatively prime. There's nothing that goes in besides a 1. So we can't factor the top to cancel anything with the bottom. We're done. Okay, I'm going to section that off for letter A. Now letter B. Okay, we're adding fractions. First thing you have to do is decide what the operation is. Addition. We need an LCD. So our LCD is going to equal, the lowest number that 5 and 10 go into is a 10. Now here's a clue. The first fraction has an x in its denominator, the other one doesn't. If one has it and the other doesn't, they are both going to need it. Okay? So we're going to need an x in both of them. One of them has it, the other one doesn't, the other one's going to have to get it. So now make a big long fraction bar, put 10x in the bottom, and compare what you have, the 5x, to what you need, the 10x. We're missing a factor of 2, because we already have the x down there, right? So we're going to multiply in the front, hugging at 4x minus 1 with parentheses. The front 1 by 2, top by 2, and the bottom by 2. So distribute the 2 inside. We get 8x minus 2, all over 10x, which is what we want. Times 5x is 10x. Bring down your connector sign, the plus, and then compare the 10, what we have, to what we need. We need 10x, so we're missing a factor of x. So the top numerator is a binomial, hug it with parentheses, and squeeze in the fact that you're multiplying the top by x and the bottom by x. So now distribute the x inside. X times x is x squared, plus 5 times x is 5x. Equals, make a road map go down. Okay, combining like terms in the top, we look at that x squared. There's nobody like squared. Just bring him down. The 8x and the positive 5x are like. They make a positive 13x. This is the combined like term step. And we're left with a negative 2. That's all over 10x. Now, how silly. There is no way we're going to be able to factor that trinomial and have 10x be one of its factors, right? So why bother factoring the trinomial, whether it factors or not? It's already simplified. Okay, letter C. It's addition. You first have to see that. We're adding fractions. What do we need?
LCD.
An LCD. Good, Connor.
Would it be 4?
Yep. 4. Now, trick. The lowest common denominator, when there's variables, x and x squared, is the one with the highest power. So who are you going to choose, x or x squared, Nick Renato? X squared. The lowest common denominator is the one with the highest power. Just like the GCF is the one with the lowest power when there's variables. So we make a fraction bar. We put 4x squared in the denominator. Then we compare what we have in the first denominator to what we need, 4x squared. What are we missing a factor of? An x. Now there's just a poor old 3 up top, isn't there? So we don't have to hug him with parentheses. Just put times x, top and bottom. So x times 3 is 3x. Bring down your plus, because we're adding, and compare 2x squared to 4x squared. Hey, we already have the x squared. We're in luck. It's easier, isn't it, that way? What are we missing a factor of? A 2. So you can either front multiply or back multiply by 2. I front multiply sometimes when it's a binomial that I have, and I multiply a monomial. I want the monomial in front of the binomial to distribute. So 1 times 2 is just 2. Now there's no way we can factor 3x plus 2. 2 and 3 are relatively prime. So we're done. Okay? Now it's important that we read this next step. Each of the combinations in exercise 1 should have been reasonably easy because each denominator was monomial. If this is not the case, then it is wise to factor the denominators before trying to find a common denominator. My Mod 1 class had 5 minutes to work on their homework, and I got a chance to walk around and check it. And one boy raised his hand, and he said, Ms. Walker, is this right? And what he had done was he'd taken the problem like this, and he had not factored his denominators. And then he made a simple mistake in his head in the end, and he didn't get the answer right. If they are binomial denominators, I have some kids multiply them together to get an LCD. That's a mess. Always get in the habit when you're adding or subtracting fractions of factoring your binomial denominators. We can take a 5 out of there, and we're left with a y minus 3. Now, get rid of that old denominator. If you don't, there's too much stuff to look at. And I'd make a squiggly line down here because I want to separate my denominators. And then factor the y squared minus 9 is y plus 3 times y minus 3. I always like to go back and get rid of y squared minus 9 after I've factored it, because I look back to make sure I factored it right. Okay, so we're going to need an LCD. Now we have, we have a 5. Do they both have a 5? No, but if one has it and the other doesn't, what happens? They're both going to need it. They're both going to need it if one has it and the other doesn't. Yes? Okay. Now, what do they both have? Y minus 3. So they already have that y minus 3 in common. We have to write that down. Now, one has a y plus 3, the other doesn't. What happens? They're both going to need it, y plus 3. So they're both going to need to have 3 factors. So we make big long fraction bar, 5 times the quantity y minus 3 times the quantity y plus 3. And we compare what we have, my pen's pointing at it, to what we need. What are we missing a factor of? Y plus 3, yes. Now y plus 3, is that not a binomial? Isn't that a binomial? All right, so I'm going to back multiply, because it's a binomial. Put it in back, I mean. The first fraction by y plus 3, top and bottom. Now that denominator already has all the factors it needs. Its new numerator is what we get when we distribute the 4 inside. It's going to be 4y plus 12. Bring down your plus. Now compare what we have to what you need. What do we need now in the second fraction? A factor of 5 in its denominator. So we're going to multiply top and bottom of it by 5 to get it in higher terms. So 5 times 5, 25. Equals 4y plus 37 all over 5 times the quantity y minus 3 times the quantity y plus 3. Now, I'm going to have you draw an arrow right there, and I'm going to have you write, it's always okay, almost 99% of the time it's okay to leave your denominator in factored form. You don't have to actually multiply all that stuff in the denominator together. Leave denominator in factored form. That's so that if the numerator can be factored, you'll be able to cross-cancel and reduce it. And there's no way to factor 4y plus 37. Right? Okay. I'm going to have you keep that out. Or you can put it in your binder, but have it handy. And take out your 6-7 practice. And we're going to do a couple of 6-7 practice together.